my name is Margie Brenner, and I'm with the Wind Energy Center at University of Massachusetts Amherst. And today I'm speaking with Dr. Zach Westgate. Dr. Westgate is an associate professor of civil engineering at the University of Massachusetts Amherst. He received his doctorate from the University of Western Australia and his master's degree from UMass Amherst, both in geotechnical engineering. Zach has over 15 years experience as a consulting engineer and manager for multidisciplinary design firms, geotechnical contractors, and specialist consultancies in the marine energy industry, and is currently a consultant at the Norwegian Geotechnical Institute. His experience and research interests include offshore geotechnics, foundation engineering, pipeline, riser, cable seabed interaction, experimental methods, and soil interface mechanics. He's an active member of the Society for Underwater Technology and sits on both the Offshore Site Investigations and Geotechnics and Marine Renewable Energy committees. He also serves on technical committees related to offshore wind and pipeline riser standards development, and he is a registered professional engineer in several states. Thank you for speaking with us today, Professor Westgate.
As a lot of engineers will probably answer, I was always mechanically inclined and so naturally gravitated towards the engineering field. While that's true, I didn't really expect to be an engineer. It was something that my parents had always encouraged me to do, and ended up starting in engineering as a major at UMass. But I had switched majors a few times and ended up getting a degree in something different. But what drew me back into the field was working in Boston, actually, after having graduated, and seeing the Big Dig in progress. So I don't know if you're familiar with the Big Dig, but it was the Central Artery Project, this was 20 years ago. And a lot of really interesting geotechnics happening. It didn't make for good traffic, of course, but getting stuck in the traffic and seeing a lot of the the underground construction activities and the tunneling activities was quite exciting and interesting. And so that kind of drew me back into, my interest in going back and getting my degree in civil engineering. So I kind of went in with the interest with the knowledge that I'd want to be a geotechnical engineer, which not many people do. They come into a civil engineering program, it's like, oh yeah, I want to be a structural engineer. And then they find out there's transportation, there's environmental, there's all these other things. And I was fortunate enough to get an undergraduate position working for my future advisor, and he happened to be doing some work with in offshore wind, and this was back when Cape Wind was sort of midway through its trials and tribulations of trying to get to be a real project. And so part of my research or my work for him at the time was to do a little bit of research on that and develop essentially a very long white paper on the topic. And that's what kind of got me interested in offshore wind energy. And then I stayed on for my master's degree, and it was in research that was geotechnically focused, but peripherally related to pile foundations for offshore conditions. And that kind of started me on the track to be an offshore geotechnical engineer. So, well, disclosure, I've only been here for one semester, so I've only been able to teach one class. And that was foundations for the undergrads. So this was an all senior class, and it was great. It was my first real introduction to teaching at that level. I hadn't taught in quite a long time since my master's days, and helped out a little bit during my PhD time at the University of Western Australia. But yeah, it was great teaching a group of seniors, because foundations is sort of my bread and butter. That's where a lot of my experience is through my industry involvement through dozens of projects over the years. So that was quite nice to get into and be able to bring some of my experience from the field and industry projects into the classroom. Mm-hmm. This coming spring, I'll be teaching advanced advanced foundations. So that's the graduate level of that class. So that'll allow me to get into some of the more challenging aspects that I kind of had to, gloss over for the undergrad level. So I'm really looking forward to that. And then, because there's not really an established offshore course here, I'm going to be developing that for the fall of 22. So I'm really looking forward to doing that over the spring and the summer. And that will really allow me to kind of bring my experience to bear in the classroom. So that's pretty exciting. What I think is going to be quite rewarding, or at least what drew me into it, is the idea that I can try to steer my own research agenda. That was very attractive. And as I mentioned, designing the courses, I think I get a lot of reward out of that personally, because it allows me to really kind of bring my industry experience to bear into the classroom. And I think that's extremely valuable from an educational perspective. But I think what's also rewarding is, and through my experience so far, is just the connection with the students. I think that having that one-on-one interaction is good, and really being able to kind of connect with the student and see that kind of aha moment, when you really get the point across and they understand something that they hadn't previously. And I guess as an engineer, one of the most rewarding aspects of what I've done over the last decade and a half is just doing something for society, right? I mean, doing something for the greater good. And that really comes through in energy, right? Like, everyone needs energy, the world needs energy. The forms in which we get it are certainly, more on the controversial side. And I've been working in oil and gas for almost my whole career. So it's been really nice over the past few years to make that transition from, traditional energy sources to towards more renewable sources, and be part of that, and be part of that transition. So that's been quite rewarding to be, part of that whole global shift in thinking about how what we do as a society will impact our planet and our longevity on this earth. So it's been good to be part of that. I guess one of the challenges that the industry here in the Northeast is having is with a specific soil type, a soil condition that we're finding all over the eastern seaboard. And it's a particular type of granular material. I shouldn't call it sand, because it isn't, but it's this green sand. It's called glauconitic sand. And there's quite extensive deposits of it, quite thick. And there's actually a big risk to installing, these monopile foundations through these materials, because they're quite dense. So they have a high resistance to installing piles through them. And they actually change from a granular material into more of a fine-grained clay, essentially, which changes its geotechnical behavior, of course, but it poses a lot of uncertainty, because as geotechnical engineers, we're just not used to working with such a material that changes between two between two extremes, really, going from a sand to a clay, just in the process of installing your offshore structure, and then having to deal with that new soil type over the design life of what you're building is certainly a challenge. So we've been able to generate interest in the industry between several developers. Some of it's a little bit confidential, but I can certainly say that the major developers here on the East Coast have now kicked off what's essentially a joint industry project on this topic. And there's several universities involved, 2 UMass campuses here, as well as UMass Dartmouth, and also Rutgers University in New Jersey. And there's several contractors as well. We've really got a great collection of experts that's taking part in this project. And we're in the process of kicking off some field work this month, and really getting into the nuts and bolts of the project, and certainly looking towards other participants getting involved over the next year or so, and having this glauconitic sand project grow into something bigger. But it certainly has a very big implication on the feasibility and the optimization for a lot of these offshore wind projects on the East Coast. From the bigger picture side, I think, at least in the short term, it would be good to see the whole permitting and approvals process a bit more streamlined, right? I mean, it's taken us a long time to get to this point. And I think there's some things that can be done to sort of expedite that. I mean, the BOEM has sort of a formula for how they step through a project and go through the different approvals. And we've seen the delays with Vineyard Wind, of course. And I think now that sort of the roadmap has been laid out and the process established, that the next several projects on the East Coast should go a little bit quicker. But it would be nice to see, I suppose, improved collaboration through, I suppose, what you'd call environmental groups and the maritime industry, right? Because all these issues still come up, right? If you look at Cape Wind 20 years ago, you certainly had the migratory birds issue, you had the migratory whale issue, you had the fishing industry issues. We've seen some improvements there, but we still are concerned about, the migratory species problems. That definitely remains to be solved. There's some things we can do on, like, noise pollution, for example, things like quiet foundations. When you're offshore driving piles, it's loud and it takes a long time. So the impact on marine mammals is certainly real. But there's definitely things that are happening on the research side to move away from pile driving offshore, or at least make it quieter. That can be providing, sound deafening solutions on the equipment itself, bubble curtains, which have been in use for a long time, but also moving towards more of like a vibratory foundation installation approach rather than driving piles with impact hammers. So I think there's more things that can be done there in the short term to make sure that these things happen as quickly as we really need them to. And then I think in the long term, of course, once we kind of use our real estate here on the East Coast and the shallower waters, it's going to be getting into floating wind very quickly. And of course, that's mostly on the West Coast, but there's a long way to go, I think, in terms of bringing down the levelized cost of energy for floating wind to make it as competitive. And there's certainly some interesting things going on with structural and foundation solutions to help make that happen, including work here at UMass, with the Wind Energy Center, and particularly Sanjay and Don doing work on the multi-line ring anchors. So I think things like that will help optimize the overall site layout and the foundation and mooring configurations will certainly make those projects more economical.